Hey there, macro folks. This is Mr. Hooker, and today we are doing GDP CPI video number 3. So let's get to it. So we stopped where the cars video was. I'm not showing cars. If you want to watch it, it's a really good show on how that all works. Um, Today we're going to pick up here on this practice question. Suppose country A sells 100 million worth of goods and services to country B. Country B sells $50 million worth of goods and services to country A. They are the only two countries in macro world. So net exports in country B equal negative 50 million, A equals 150 million, A equals negative 150 million, or B equal 50 million. Your answer is A. B equals negative 50 million. So there we are right there. B equals negative 50. So 3, income spent on imported goods. Either A represents income that has leaked across national borders, must be subtracted from spending data to calculate an accurate value of domestic production, is income that is not spent on domestically produced goods and services, or A, B, and C are all correct, and A, B, and C are all correct. So let's look at this. Real GDP is a measure of aggregate output. So we have nominal GDP and we have real GDP. Nominal GDP is today dollars. We are in 2025. I'm making this September of 25. So September 25 dollars are nominal GDP. Real GDP would be inflation adjusted. And so they are preferred because that way you can compare across time. So you can look at them forward, you can look at them backwards. You don't have data for forward, but you can project stuff. And so you could also look back, you can compare it to 2020, 20, you know, uh, 2015, 2000, 1995, 1987, whatever. Whenever you want to look at it, you can look at it, right? So, however you want to do that, you can do that. That is the beauty of real GDP. If you do it with nominal numbers, it means absolutely nothing because prices have changed. Stuff's more expensive now. Like cost of going to the theater way back in the day was a quarter. I mean, you could go to the theater, get a popcorn, get a drink for 50 cents. Not in my young day, not in my youth, but I mean, like, my father's days. When I was young, I think the whole experience when I was a kid was $5. Um, so, it's a thing. And so that's why you don't want to do that. So aggregate outputs, the total quantity of final goods and services the economy produces. We measure that with real GDP just because that's good to compare over time. And that's the total value of the final goods and services produced during a given year, calculated using the prices of a selected base year. And nowadays, it's not a given base year, but a chained 3-year period. So just note that. Um, Nominal GDP is the value of all final goods and services produced in the economy during a given year, calculated using current prices. Okay. So calculating real GDP, um, to calculate it, it's not too much difference. So you want to calculate it if prices had not changed. So you calculate it using the value in year 2 expressed in year 1 prices. So I have this table here. It's a really simple economy. We're making apples and oranges. Two very different things, taste very differently. You might like both, but for different reasons, right? So in year 1, I'm producing 2,000 apples at a price of 25 cents. I'm producing 1,000 oranges at 50 cents. So my GDP in billions of dollars is 1,000. My real GDP, because year 1 is my base year, is 1,000. Year 2, I'm producing 2,200 apples at a price of 30 cents. We have inflation, ladies and gentlemen. I'm producing 1,200 oranges at a price of 70 cents. Once again, we have inflation in oranges as well. GDP in year two is 1,500. So basically, I'm taking the 2,200 times the 30, the 1,200 times the 70, I'm going to get the 1,500, right? But to get real GDP, I'm going to take the 2,200 times the 25, the 1,200 times the 50, and that's going to give me 1,150. So it's a little bit different calculation, but I get a number that is comparable to year one. So year two quantities, year one prices. And so if I go out to year three, I would do the same thing. I would use year three's quantities times year three prices to get nominal GDP, but then year three quantities times year one prices to get real GDP. It's a simple thing. It's not terribly difficult. Just remember, always use base year prices for base year prices and current year quantities to get real GDP. Okay? So nominal versus real GDP 2002, 2012, 2022. So 2002 nominal GDP was 10,929. Real GDP 2012 was our base year, which means 2012, those two are going to be equal. But our real GDP was 13,488. Okay. 2012, 16,254 in both because that is your base year. So it's 100% of real. 2025, nominal was 25,464. And then your real GDP is actually 20,015. So you can see there how your real, when it's, after, when your base year is after um, the year, like, so base year was 2012. So when we go back and you're looking at years when it was cheaper stuff, you can see how real GDP is greater than the nominal GDP. When we are equal, it's the same. And when we are after and stuff was more expensive, real GDP is less than your nominal GDP. It is the way it should be. Except for the base year, real GDP is not the same as nominal. Method of calculating that in real GDP is based on um, an early base year and GDP growth rate calculated on late base year. So it's a 3-year chain to average is what that is what we use. So there's actually, like, we're doing it to make it easy for you in this class. We give you one base year. In the real world, we used a 3-year weighted average. It's okay. It's still a number, right? It's still not that difficult to deal with, I promise. So if you get into economics, I promise it's not that difficult to deal with. GDP per capita is average GDP per person. It's not a policy goal. It's not a one-to-one match between GDP and quality of life. It's useful for some things, just not so much for like looking at policy stuff. We use it. Economists don't use it a ton. Sociologists use it a lot, but it's a measured goal. So that is a thing. Um, for the meaning of life, rich is better. You see here, um, GDP per capita across the bottom, life satisfaction scale on the vertical. Um, so higher on that scale, and then across the way. So high GDP things. You've got people on the um, that have not as much money that are still pretty high on the life satisfaction scale. Richer countries on average have higher well-being than poor countries. Um, Money matters less as you grow richer. As GDP goes up, the average gain in life satisfaction per extra dollar is smaller and smaller. That's a marginal utility gain issue. Marginal utility gains diminish. There's that diminishing marginal utility problem, right? So as you increase things, marginal utility of those things diminishes. So dollars are just part of those things. As I give you more and more dollars, each additional dollar means less and less. Um, so this is why pretty much everywhere that you are, people that are in the middle tend to show greater happiness than billionaires. Billionaires are unhappy people for the general in general. Um, this is that third part, money and everything. Middle income nations seem to be more satisfied in their lives than richer nations, and it's the same for people. Middle income people seem to be happier in their lives than extremely rich people. And it's one of those things. It just seems to be that way. Like it's useful to have a single number representing the overall level of output. Useful to have a single number representing the overall level of prices. Aggregate price level, measure overall level of the prices in the economy. So we call this the CPI. So to measure the aggregate price level, we calculate the cost of purchasing a market basket. So this is 200 items, roughly 200 items that the average household purchases on a regular basis. So the market basket's a hypothetical set of consumer purchases of goods and services that we do on a regular basis. So suppose a typical consumer bought 200 oranges, 50 grapefruit, and 100 lemons over the course of a year. So we'd look at what it was. Um, Oranges were 20 before the frost, 40 cents after the frost. Grapefruits were 60, then a dollar. Lemons were 25 cents, then 45 cents, excuse me. So you would just take those. Before the frost, your basket was $95. After the frost, your basket was $175. So, you know, if we had a frost, you'd have a problem. Your cost went up by like $80. So it's a thing. So we're looking at what we call price indexes. All indexes are the same. You'll have a number of indexes in here. We're going to calculate them exactly the same. So pay attention to this version because everything else after this will be exactly like this. And if you get it the first time, everything you go after this will be like, oh, that's just like the last one. And it'll be awesome because then you won't have to put a whole lot of effort into it. You'll just have to figure out exactly what the numerator and the denominator are. So it'll be good. So price index is just the cost of purchasing a given market basket in a given year, where that cost is normalized. So it equals 100 in the base year. So we do it a lot for like cost of living indexes and all those kinds of things. So the cost price index for a given year for the CPI is the cost of the market basket in whatever your given year is, divide by the market basket in the base year times 100. And your base year is always going to be your denominator, by the way, no matter what index you're using. So the cost of whatever it is in the base year is always going to be your denominator. So there's that. So the inflation rate is a yearly percentage change in the price index. So it's not from one year to another. It's just that whole thing. So when we're looking at that, it is one year to another, but that is the inflation rate. So the CPI is not the inflation rate itself; it's the change in the CPI that is your inflation rate. So basically, it's year two minus year one divided by year one times 100. So this is the simple percentage change formula: 2 minus 1 divided by 1, or new minus old divided by old times 100, or move your decimal place 2 places. However you do that, that will get you there. So that's really all you're doing with that is 2 minus 1 divided by 1, new minus old divided by old, however that is. And that will get you your inflation rate. But you're you're going to do that one. It'll be simple. I think we're in the 200s now. So, I mean, we're a ways away from our base year at this point. So, oh, it's about 80. The new basket's about 80,000 items, excuse me. Um, New basket's about 80,000 items. So, Let's look at it right now. This is what's in the basket. This will be our last slide for this video. Apparel is about 2.5%. Housing is about 44, almost 45%. Um, Food and beverages about 14.5%. Transportation minus gasoline is about 13.5%. Medical care is about 8%. Education and communication, that's a weird mix, about 6%. Recreation's 5.5% or so. Motor fuel is about 3.3%, so it puts it together. It has its own category. Other goods and services are about 2.7%. So that's kind of interesting. So like I said, that's your last slide for this one. We will catch you in video 4. Y'all have fun.